So this is a syllabus for AC and ventilation system design training syllabus. Okay. Hope you have gone through the complete syllabus, module 1 to module 8. And we
Mhm.
start with the last week introduction to architecture design. Okay, where you understand the basic architectural design, so
Yes,
that
sir.
it will helpful for you to design the MEP systems. Okay,
Mm.
so
Mm.
that we will have some basic idea how and each and every space planning is done, like basement, ground floor, the number of floors, then each and every spaces like a staircase, plant rooms, FHU plant room, water plant room, firefighting plant room, the tie-in points, everything we have some basic idea. Okay.
Mm.
Okay, now before we go into the technical parts, okay, there are a lot of technical information is there, but what I need, I want you to start with some basic, okay,
Mm.
because we are talking about we are studying air conditioning system design, right? Air conditioning means it's about climate condition, okay. We talk about climate, okay. Say for example, outside you have a different conditions, and inside the space you have a different conditions to maintain your comfort level. Okay, so we are going to study some basic detail. I will be sharing you some Excel sheet, okay, to get some basic idea. Okay, what is latitude and longitude? Okay, why it is important? Say for example, when you talk about our globe, right? It's a round, right? It's a globe.
Mm.
Okay. Uh, when you talk about air conditioning, it is not only for particular place. You are not studying air conditioning for only for Middle East. Okay, it is for the entire global. Okay, maybe tomorrow you will go to, say for example, United States, or you may go to Singapore, or you may go to Japan, or you may go to European countries. Okay, so you need to understand that what is the climatic, the outside condition, correct?
Yes.
Okay, so that is the latitude and longitude. Latitude and longitude, what it in the Earth, you are going to get the coordinates. Say, for example, when you are going to do the calculations, okay. Say, for example, you are going to work with a half thermal load.
Can I ask you, we can record this section?
Yes, I am already recording. Yes,
Okay, after you can send me.
I will be sending you. Yes, yes.
Oh, thank you so
Okay,
much.
okay. So latitude and longitude is basically what it is about the Earth location. Okay, whenever you start with the calculations, air conditioning calculations. Okay, say for example, I will be doing for Middle East. Okay, so in the Middle East, maybe you can say Dubai. Okay, so for the Dubai, you will be having a latitude and longitude coordinates.
Yep.
Clear what I'm saying?
No, just repeat again. As I just
The
listening.
coordinates. Okay, now let me open one Astray Meteor. Okay, so if you go to this particular, sorry, 1 minute, I will be opening another one. Uh, yeah, there is one website called Astray Meteorological. Okay, can you see that website? 2009,
Yes, yes.
2013, 2017, something like that. Okay, so when I go to Asia, Station Asia. Okay, if you go to United Arab Emirates, for example, or you want to go to, say, for example, Abu Dhabi International. Okay, so when you go
Mm.
inside, you will find Ashray fundamentals, right? So here,
Yes.
can you find out there is a latitude and longitude?
Yes, the
So this,
24.4 is the top
yes,
north.
yes, yes. So each and every location, say for example, if I go to Dubai, okay, I have a latitude, longitude. Can you see here 25.25,
Ye-
and when you go here
Yes,
24.43. So this is the coordinates in
yes.
the global, in the globe. Say for example, this is the globe, right? This is the globe. So you have a coordinates, latitude and longitude. It's like x, y, z, x, y.
Uh,
Okay. So this is the latitude and longitude. You will find out some basic idea when you go through this video. You will get some idea about what is latitude and longitude. Okay.
okay.
Then there is elevation. Elevation is about where your the plot is located. Say for example, from the sea level. Okay, say this is 27 meter, means 27 is from the sea level. Okay, so this is the sea. From the sea, I am 27 meter above. Clear?
Yeah, clear, clear.
Okay, so this will also will affect your air conditioning calculations in future.
This is a major effect to our calculation.
Yeah, this all will affect our calculation. Yes, that is what I'm trying to say. Okay,
Okay.
this is about density of the air. You heard about density of the air, right?
Yes.
Okay, when you heat the air or when you cold the air, your density will remain same or different.
It's, uh,
Can you answer?
Yeah, it will different.
How? And can you
It
give
will,
one example?
can say.
Okay, I will tell you very simple. Can you take one
Okay.
glass of water, okay, and
Hmm.
there is a hot water and cold water mixing.
Okay.
The hot water will be top or bottom.
What? Uh,
Okay,
sir.
the hot water will be on the top side because it is a light density. It is a light density, okay, and lesser
Hmm.
density you can say. When you talk about cold water, it will have a heavier density. Okay, so that is why the hot water, whenever you heat the water, okay, what will happen? The hot water will become on the top of the surface, and the cold water will go down. Okay, so you will study about density about. Okay, so when you go to my list of videos, you will talk about latitude and longitude. Okay, then you will talk about dry bulb temperature and wet bulb temperature. What do you mean by dry bulb temperature and wet bulb temperature? So whenever you're in the room, okay, so when you take a thermometer, you will measure the temperature. Okay, so that is a
Hmm.
dry air. It is purely dry air. Okay, so that is about dry bulb temperature. When you talk about wet bulb temperature, it is about moisture content. Okay, how much moisture is there in your air properties.
True. Okay.
Okay, so you will talk about dry bulb temperature and wet bulb temperature. There is explanation. You will watch the video. Okay, and there is a humidity explained. What do you mean by humidity? There are different type of humidity. One is a specific humidity. There is a, you can say that, relative humidity. Okay,
Hmm.
so you can you explain? You have idea about what do you mean by humidity? What is absolute humidity and what is relative humidity?
I'm
Okay, you will
not.
find out this in this video. Okay, you will have a very clear understanding. Okay, remember you said that you want to study the equipment schedule, right?
Yes.
You want to study the equipment schedule, but you cannot go equipment schedule directly. Okay, for example,
Yes.
you receive a equipment schedule from say for example from the you are preparing equipment schedule. Since you are a consultant, you are preparing
Hmm.
equipment schedule for fan call unit. Okay, in the fan call unit, what you will place it. Say for example, when I am going to prepare my equipment schedule for fan wall, what I will place it here? I will make a schedule, right? I
Yes.
will make a schedule here. Okay, so maybe I will provide FCU reference. Correct?
Yes. FC reference,
Okay.
room
Then
reference.
you may give the room reference, right?
Yes.
Okay. Then you will provide what you will provide. You will provide total cooling load, right?
Total kilowatt. Yes.
Total cooling load.
Yes.
Then sensible cooling load. Okay. Will you
Then
provide
provide
latent cooling load?
entering and driver
No, no. I will tell you. For
entering.
example, you are going to enter first FCU reference. Okay. Then
Yes.
room reference. Then you are going to enter total cooling load, right?
Yes.
Then you will enter sensible load.
Sensible.
Okay. Then what you will enter? You will enter latent load, right?
Yes.
But normally, will you find latent load in the schedule?
Entering
No, no. What
prevent
I'm saying,
temperature effect.
there is a latent load, right?
Yeah.
Okay. Will you find latent load in the FC schedule?
I didn't know.
You don't find. Why you don't find? Because the total cooling load is nothing but sensible cooling load plus latent load. So when you have a value of total cooling load, when you enter sensible cooling load, you can able to easily find out latent cooling load by
Yeah,
subtracting the value. The difference is
the
latent
total
load.
kilowatt minus sensible, then we will get
Yes,
less.
yes, yes. Then you have a airflow rate.
Yes.
Okay. Then you will be having air on coil temperature.
Ah,
Correct?
yes.
Okay. Then you will be having
Living on
air
coil.
off coil temperature.
Hmm. It's been living and on coil, right?
Off
Off.
coil, on coil and off coil temperature. Right? Then after that, you will be having a chilled water flow rate. Right?
Yes.
So this is what you will find in the schedule. Will you find more than that?
Then power, electrical power.
Yes. Okay. FC schedule. I will be entering you the value here for the power. Okay. Power. Power is nothing but electrical load. What else you will find? What else you want to
Electric
know?
drive. Uh,
What else you want to know in the FC schedule? For example, you want to study the equipment schedule. Okay, so first one is we will start with the FC schedule. So in the FC schedule, you have a FC reference, room reference, total cooling load, sensible load, latent load, air flow rate, air on coil temperature, air off coil temperature, chilled water flow rate, power. Right?
Yes.
Okay. Now, what do you mean by total cooling load? It is about sensible load plus latent load. Right?
Yes.
Okay. Whenever you talk about sensible load, you are talking about dry air. It is directly related with the dry bulb temperature. Okay.
Okay.
So I want you to study what is dry bulb temperature. Okay. When you talk about latent load, it will talk about wet bulb temperature. Okay.
Mm.
Okay. So when you know the dry bulb temperature and wet bulb temperature, it is easily to calculate what is relative humidity. Right?
Yes.
What is relative humidity? The percentage of amount of water vapor in the air. The percentage.
Okay.
Okay. Say for example, I have a dry air. Okay. I will be having a dry air of 1 meter cube. Dry air. In that, I have a 0.5 meter cube of water particles. Say for example. Okay.
Mm.
So what is the relative humidity? Can you tell me? This example. Okay. You will get a complete lecture in the video. But I'm just saying what is relative humidity? It is a percentage of amount of the percentage of water vapor in the air. Okay. So it will be normally in percentage.
Yeah,
Correct?
normally we keep in 50%,
50
60%.
percentage, 30 percentage, 40 percentage, 60 percentage. Okay, so that is the relative humidity. Okay, then we talk about absolute humidity. What do you mean by absolute humidity? What is the amount of water in the air? Here we talk about percentage. Then we are talking about amount of water. How much amount of water? Gram of water per water vapor per kilogram of dry air. Clear?
Yes.
So
So how
say
much
for example,
percentage of the
I have a
water?
1000 kg of dry air, for example. Okay.
Mm.
Okay. In that 1000 kg of dry air, maybe I will be having 10 gram of water vapor. Okay.
Mm.
So this all you will find in the psychometric chart. Okay. We will come step by step. Okay. Then I talk about density. So densities, you are going to start. You are going to learn about the physics. Okay. Because why the density matter? Because you are studying the climate. Okay, when you say cold water, you have a heavier density. When you say hot water, it will have a less density. Right? That is why whenever you have a glass of water, okay, when you try to heat, the cold water will be below.
Okay.
Okay, and the hot water
Above.
will be above. Right? Okay, so the hot water will be above. So this is why you study about density. You will find in this video. Okay, then the specific volume means what? It is a ratio of density. Okay, you will understand exactly what is the specific volume. Okay, in that one amount of water, that means that is a volume, right? It is a volume. So what is the unit of density?
H.
It is a kilogram per meter cube, right? So what is the kilogram per meter cube? In 1 meter cube, what is the kg of water is available? That is the density. Or what is the property weight? The in 1 kg, in 1 meter cube, okay, what is the kilogram? Say for example, if you take a paper, if you put a paper in 1 meter cube room, okay, if you fill with paper, you will get a weight. Okay, and if you take stone, and if you put in inside the room of 1 meter cube, it will be heavy, right?
Mm.
So which will heavy more, stone or paper?
Stone.
Stone, right? So when you say paper, you will find, say for example, you will find on just example, okay, you will find 1 kg per meter cube. And when you talk about stone, maybe it will say 10 kg per meter cube. Okay, so which is heavy? Stone is a heavy. Okay, so this also 1 meter cube, this also 1 meter cube. But if you fill with paper in the 1 meter cube room, if you fill with stone 1 meter cube, you have a difference. So that is called density. Okay, you will study about that. Then you have a specific volume. Specific volume means what? In meter cube, how much kg you can accommodate. It is a reverse. Okay. Okay, then we talk about specific volume, then we talk about dew point temperature. What do you mean by dew point temperature? The dew point temperature means when you say the dry bulb temperature is 25 degree, for example. When you say wet bulb temperature, also 25 degree. So that means what? It is saturated. You heard about temperature. Maybe you talk about news, climate. They say the climate conditions. They will tell about what is the dry bulb temperature, what is the wet bulb temperature, or they will tell about what is the dry bulb temperature and what is the relative humidity. Correct?
Yes.
So that talk about dew point temperature. Okay. So when you say the dew point temperature, that means that time the RH will be 100%. Clear?
Yes.
Okay, I'm just giving you introduction, but after you see this video, you will have a better idea next week. Okay.
Okay.
Okay. Then you will talk about enthalpy. What do you mean by enthalpy? Each and every air there is energy, right? Say for example, every person has energy, different energy. Okay, maybe you have some different energy. I have some different energy. Maybe the different healthiest person, or maybe strong person, or weak person. Everyone have a different energy, right?
Yes.
Okay, say or we will talk about age wise. Okay, so when you talk about the babies, they have a less energy. When you talk about 10 years students or 10 years kids, they have a different energy. And when you talk about 30-year person, have a different energy, right?
Yes.
So similarly, in the air also you have an energy. Okay, say for example, you have a cold air, you have energy. It's energy, right? So cold air, maybe you can use it for to cool your room. So that is energy.
Yes.
Maybe you have a hot air. Hot air, maybe you can heat something you can heat. So that is also energy, right? So that will talk about enthalpy. Okay, so thermodynamics. You will also study in thermodynamics. Okay, then after that you are going to fluid mechanics. Okay, fluid mechanics means basically you try to understand each and everything like about density. There are a lot of things about fluid mechanics, right? Okay. Then after that, you will also study the what is thermal comfort. Remember, whenever we do air conditioning, why you are preparing equipment schedule? Why you prepare for FCU equipment schedule? To size the equipment.
Size the equipment.
Okay, that equipment for what? To to maintain the thermal comfort. For the cooling, to maintain thermal comfort. Okay, so you also going to study what is thermal comfort. Okay, then after that you also understand what is the sensible heat and what is the latent heat, what is the difference. Okay, what do you mean by heat capacity, what is specific heat, and what do you mean by calorimetry. Okay, then you talk about specific heat capacity, types of heat transfer. There is a conduction, convection, radiation. Okay, whenever you talk about air, okay, so when you heat the air, remember when you try to heat something, okay, a best example is you take a vessel and you try to heat. Okay, so the heat will be transferred through the material, correct?
Yeah.
So there is a vessel. Okay, you're heating the material through the vessel. Okay, so that means there is a conduction happening. Okay. Okay, the convection means it is inside. Inside the heat will be transferred. It will have a the energy. Okay, which will convert from liquid to vapor. Okay, so that we talk about the convection. Then radiations. Say for example, when somebody standing here and when there is something heat, you can able to absorb the heat, right?
Yes.
Okay, say for example, you are going to near the fireball area. Okay, so you may see that heat which is coming to, it's a radiation heat. Clear? Okay,
Yes,
so
yes.
you also understand what is the conduction, what is convection, radiation. These are all the things we will study in the in the basic things so that you can able to very clearly you can prepare the equipment schedule. It is not just preparing, just using the half thermal load calculation, enter the value, get the cooling load, enter the value, then I don't know what is cooling load and what is sensible load, what is latent load, I don't know, but I know half calculation. It's not like that. We also study the basic fluid mechanics. Clear? Yeah.
Clear.
Okay, then you also understand about thermal radiation, convection, and the heat equation. Okay, in the best very important equation is in the HVAC, M equal Q equal mCp delta T. You heard about this equation?
Yes.
Okay, so this basic, by using this equation only, we are going to derive all the calculations. Okay, so that is the thermal the heat equations. Okay, then understanding the thermal radiation, then also you study about introduction to heat transfer, convection, convection, radiation, then laminar flow and turbulent flow. What do you mean by laminar flow, turbulent flow? Okay, there are three types of flow. You have a laminar flow, transient flow, and turbulent flow. Okay, so whenever you have a pipe or whenever you have a duct,
Okay.
right? Okay, so when the air pass through the duct, okay, it will change his condition depends upon the velocity. Okay, say for example you have a low velocity, then you have a different reaction. If you have a medium velocity, you have a different reaction. Okay, if you have a high velocity, you have a different reaction. Okay, so that will affect your equipment, right? Because remember, whenever I think we didn't add one more thing. Which one we didn't add? You can remember? What is missed here in the equipment schedule?
Chill water inlet.
Yeah, can you just remember?
Is it chill delta the chill water or external static pressure? Okay. ESP.
External static pressure, that is called ESP, right?
Yes.
Yeah, that is very important. So this ESP, how it will affect, say for example I have a fan coil unit. Okay, I'm going to supply to one particular distance. Okay, if the distance is longer, then my pressure drop is more. If the distance is shorter, then my pressure drop is lesser. So that will affect my calculation, affect my equipment sizing. Clear?
Depends the length, total length.
Depends upon the length. Yes, depends upon the length, it will affect. Okay, so that you will study in later. Clear?
Yeah, just want to ask you, sometimes you schedule the beginning time, FCU always keep it 50 and Pascal and the HUR 200, 500. How they, and
No, we will do the
how
pressure
they
drop calculation. We will do the pressure drop calculation based on Ashray. Okay, I will explain you how to do that.
Okay.
Okay, so now you got this idea for your assignment.
Yes.
Okay, try to watch the video, try to understand the basic. It is not about to prepare the equipment schedule, but how to prepare the equipment schedule, what is the basis. Then it is, if you see this video, okay, try to watch the video, try to understand the basic. Don't quickly watch the video. Okay, take each and every video, take a time, understand, and use ChatGPT if you want. Try to understand what is latitude and what is longitude. If you have any doubt, you can ask in the group. Okay, but get your whatever you try to see, try to observe what it is. Okay, it is not just completing the video. Try to do some assignment whenever it is
Which
possible.
video talk about this one?
I'm going to send you two Excel sheet. Okay, so that there is one link. Try to click the link and you will get the video.
Okay.
Okay, then after that there is another video. Can you talk about here? Can you see my screen again?
Yes, I can.
Yeah, so this is about psychometrics. Okay, remember we talk about psychometrics, right?
Yes.
Okay, once you complete that video, start this video, try to watch the video so that you will have a better understanding how to design the system, HVAC system. Clear?
Yeah, but we didn't take any classes in the psychometry. It will come next.
No. I will see. We will go step by step.
Okay.
Okay, nothing to worry. After some time, you can see your changes. How you learn the things.
Yeah.
How you try to understand. Correct? So, for example, you
Yes,
are
yes.
going to do the calculation. Okay, I will ask you what is the unit of density. You should know, right? What is the unit of density? What is the unit of specific volume? Okay, unit is very important in a calculations. Okay, unit is very important. Okay, say for example, I will tell you why it is very important. Okay, as I said, I told you Q equal to M C C P and delta T, right?
That, yes.
Okay, and what do you mean by M? It is nothing but volumetric and density, right?
Flow rate, right?
Correct or not? Volumetric flow rate into density, correct?
Mm,
So volumetric flow rate, what is a unit? Density, what is a unit? Specific volume, specific heat, what is a unit? Delta T, what is a unit? Then when you apply everything, then you will get Q in one unit, right?
yeah.
So we are also going to study the units, okay? And remember, you are in my group. You are getting some messages, right? In between some
Yes, yes,
messages in the HVAC. So
yes.
try to watch that video. It is just for to improve your skills, okay? Whenever you get some message, try to watch the message and get some information. Okay, there is something in that. You will keep on learning. It is about design training. You cannot learn it in a very short time. You read it. You have to absorb. Okay, try to. It's like practicing. Okay,
Yeah.
clear.
Fine. Yeah, clear, clear.